Hi Mayfield, it is Thursday, April 30th, and this is a video for my Math 6 students. We've been working this week with our virtual learning on dividing decimals, and I did print out some of the Edulastic questions. My E was not printed. Remember that those are due tomorrow, and there was a question about number 1, and the question was, you said we were doing dividing decimals this week, but this one is adding, so why is that there? And my answer was because everything we learn, it's always good to practice and review. So yeah, my point in putting number 1 was to kind of ease you into it. Remember when you're adding decimals to line up your decimals like buttons on a shirt. We're going to talk about number 2 today because I want to show you what happens with the decimal, and then I want to show you 2 strategies you might want to consider when you're doing the actual division. So initially this problem, and if you have trouble figuring out which number is the divisor, remember a division problem is also a fraction. So this is 1 36/100ths divided by 8/100ths. And then if I wanted, I could just make this fraction bar nice and long and drop it down and then bring the 1 36/100ths. And now we have our division problem. So if you're ever stuck about which number goes where, since in division order matters, that's a fun little trick. We talked this week about that when we divide, we always have to divide by a whole number. And of course, 8/100ths is not a whole number. But what we can do is multiply by a power of 10 as many times as we need to move the decimal. So I can multiply by 10, and my 8/100ths becomes 8/10ths. If I multiply by 10 again for a total of multiplying by 100, then my 8/10ths becomes 8. But in mathematics, everything is balanced, right? So if I'm multiplying my 8/100ths by 100, then I also have to multiply by 1 36/100ths by 100. And so now my problem is 136 divided by 8. This does always have a decimal. A whole number has a decimal. It's always behind the number. I'm going to make sure that I write that down and I include it in my quotient. And then we're going to solve this problem 2 different ways. Maybe one way will work for you better than the other. Maybe it's just good to look at a problem from a different perspective. So the first way I'm going to show you is using partial products. Partial products is nice because you don't have to know the exact right answer to get started. I know that 8 doesn't go into 1. And I don't know 8 times what gives me 136. But I do know that 8 times 10 is 80. And so that's less than 136. That's a good place to get started. My quotient, I'm going to multiply by my divisor. So 10 times 8 is 80. And I'm going to put it here under my 136, and I'm going to subtract. And this is going to give me my new problem. So now, 8 times what gives me 56? Oh, well maybe, there is a right answer, but maybe I don't know it right away. But I do know that 8 times 5 is 40. So notice I put the 5 over the 10 with the 1's digits lining up. 5 times 8 is 40. And I'm going to subtract again to get 16. And now this is my new problem. 8 times what will get us to 16? Well, 8 times 2. And again, notice I'm putting my 2 so the 1's digits are lined up. So this is 10, 5, and 2, lining up those decimals. 2 times 8 is 16. I have nothing more to divide, so I'm done. If I add these numbers up, I get my quotient, 10 plus 5 plus 2. So the answer is 17. Now another way to do it, it's a little bit shorter, but you have to be a little bit stronger with your math facts. 8 doesn't go into 1, so I'm going to put that X as a placeholder. And now I'm just going to look at the front of the problem. 8 times what will get us close to 13 without going over? Well, since 8 times 2 was 16, I know I'm going to need to use 8 times 1. So make sure that 1 is over the 13. And then 1 times 8 when we multiply is 8. And I'm going to subtract. 13 minus 8 is 5. And then I have to bring down my 6. So that's new to this page. We didn't do it over here. And now here's my new problem. 8 times what will get us close to 56 without going over? So if you think of your times tables, 8 times 5 is 40. 8 times 6 is my age. 8 times 7 is exactly 56. And I subtract, there's nothing more to divide, and I'm done. So this gave us the answer right away. This answer, we took it into pieces, so partial quotients. And then we added those quotients up to get 17. And I know some of you like a strategy similar to this one where you show your work on the side. That's equally great. I want you to find a way that works for you, that makes sense to you, that helps you maybe enjoy these problems a little bit. Before we go, I just want to draw your attention to question 3. In order of operations, we always divide before we add or subtract. So make sure you do your division, and then once you divide, make sure you add 42. This is going to start off as 16 divided by 4/10. You have to make that a whole number. So multiply by 10, which means the same thing has to happen here. You have to still multiply by 10, so now it's going to be 160. And then do your division, and then don't forget to add that 42 at the end. I had some people who felt they were right, but it's because they forgot to do the addition. They stopped a little early. Hope that helps. Feel free to reach out to me via Canvas email if I can help. I'm proud of you and your hard work. Thank you for participating so great this week in our check-ins. They're kind of fun. I like seeing you there. And I will see you next week. Bye, everybody.